Dear model railway friends, welcome back to the second part of our video series. We are building an information day layout, and as you can see, the layout has now arrived. Now we can lay all the tracks on it. As you may remember from the first episode of our video series, we were able to print out the existing track plan as a parts list using the track planning software. That's exactly what I did, and I have obtained all the items accordingly. And here we have laid out everything we need to build the layout, from regular track pieces to curved turnouts, crossing turnouts, buffer stops, and standard compensating pieces. From signals to electronic components like the S-feedback module M and the braking modules. So the next step is to take the track plan and roughly lay out everything piece by piece. Now I'll get the track plan ready and first figure out where I'm going to place my turnouts. Well, the track plan fits together perfectly. I haven't connected the radius 2 yet. The reason for that is because I'm going to separate everything again, this time according to the contact tracks. Now I'll take my plan with the contact tracks, and according to this plan I'll separate everything again and place the contact tracks accordingly. There are two ways to install a contact track. On the one hand, we have these ready-made contact tracks here, which I definitely wanted for my shuttle line, but I'll be making all the other contact tracks myself, of course. Now, on the layout, we've separated everything cleanly, of course. So here I've basically separated every track that is supposed to become a contact track accordingly. And now I can insert the insulators for the contact track as needed. In the past, we've already made a lot of videos on how to create a contact track, but I'd like to quickly show you again how to do it. Let me quickly remind you, turnouts cannot be used as contact tracks, but everything else can. Now, for example, K, I want to make this track into a contact track, and that's this track right here. And in order to use this as a contact track, the first step is to interrupt the ground connection on one side. We do this with an insulating piece and insulating cap, and then of course on the opposite side, since ground could also be introduced into the track from here, I need to take the turnout here and also equip it with insulation so that the track is not supplied with ground from either side. But in addition to that, our turnouts are also interconnected, which essentially means that these connections I have here now also need to be separated. Now, this is our track, and of course we have the spot where the traction current is introduced into the track for the center rail, and on this side, this is the neutral conductor, which runs from here across this bridge to the other side. So I can either insert the neutral conductor into the track from here, but in this case I don't want to do that. I want to strip one side here accordingly, and for that I need to cut this bridge. You can see it here very clearly with a small pair of side cutters. The same applies here. At this spot the bridge needs to be cut, and of course also at this spot at the end of the track exactly the same thing. Here too I have another connection, which means for my two tracks there are basically 4 spots that I need to cut. So now I take my precision side cutters and carefully insert them here accordingly. And then I snap this predetermined breaking point. Now it's also important to carefully take a small, precise screwdriver and gently press this little piece down just a bit, so that there is absolutely no chance of any kind of connection happening here in the future. We'll take care of that with the rest of the track. And now in the second to last step, I of course need to equip the corresponding side here with the insulating cap. For this, I usually use a small pair of pliers, gripping the tip of the insulating cap a bit more firmly and then carefully inserting it on one side. After that, I press the whole thing in accordingly. This way the insulating tab is perfectly installed right here, and of course I have to do the same thing with the turnout as well. That means this spot also needs to be fitted with this insulating tab, just like before. Done. Now it's important to later solder the cable for the feedback module onto the correct side. Of course, I've made the separation here, which means the gray cable for the feedback module needs to go on this track, not on that side. So I always put my finger on this side and then turn the track over. That way I also have a marker at the same time and know, okay, if I were to solder the wires for the feedback module here, then I turn the track over and realize, oh, that's wrong. That's the side that isn't insulated. So it's not this tab that's responsible, but I have to do it on this tab. And again, when I turn the track over, I see that it's exactly where my finger is, and that way I've identified the correct side. We have now installed all the contact tracks on the layout. Everywhere I've inserted these insulating tabs and also cut the tracks at the appropriate spots so that I can use them as contact tracks. Now, as an example, we will solder the cable for the feedback to the S feedback module onto contact 8, so you can see exactly where this takes place. And please pay very close attention to the Märklin color codes we use for building the layout. For us, contacts are always equipped with the gray cable. Why that is, you'll see in detail later when we do the wiring. Now, as I said, this is the track that needs to be used as the contact. This is where the cable needs to be soldered. So I turn the rail over, keep my finger on it if necessary, and then I know exactly where the tab is located. That is the insulating cap right at that spot on this side. That's exactly where the contact should be made. That means I can solder the cable directly onto this tab here if I want to. As a first step, I always warm it up a little, very gently, very carefully, and then pre-tin it. I do the same with the cable, of course. That means I also lightly pre-tin the cable, which involves applying a small amount of solder to the strands before making the final connection. This helps the solder flow more easily and ensures a good bond. I use a bit more solder on the cable than I did on the other part, just to make sure all the strands are properly coated. Then, I carefully solder the cable onto the connection point, making sure everything is lined up correctly. Once the solder cools and solidifies, the cable is securely attached and the job is done. Now you might be wondering why we solder and why we don't use these tabs. The tabs could always be accidentally pulled off. That means for a setup that's only temporary, this is truly an excellent choice. But my setup is meant to last forever and I don't want the cables to be pulled out again and again, so that's why we solder them. Now, as we can see, everywhere we have a contact rail, we've also soldered on the corresponding cable. And now I'll show you a trick, because I absolutely want to make sure before I screw the setup together that the contacts really work. Before we permanently install the contact rails on the setup, it's always helpful to test all the contact rails for functionality first. This is relatively easy to do by setting up a small test environment like this. Of course, don't forget my S feedback module, very important. Connect the ground coming from the central unit, and then also a track that is supplied directly from the central unit as a supply track. And now, for example, I simply take this contact track, which is used to connect different parts of my setup and ensure a good electrical connection. I pick up the contact track and make sure it is facing the right way so it will fit properly. Then I connect it to my feedback module, which helps me monitor how the system is working. I carefully attach the contact track to the feedback module, making sure the connection is secure. After that, I take the power supply, which provides the electricity needed for everything to run. I check that the power supply is set correctly, and then I just clip it onto my contact rail. The contact rail distributes power to all the parts of the system, so it is important that the power supply is firmly attached. By doing these steps, I make sure everything is connected and ready to work as intended. Now I have power coming in. So track power is coming in, ground is connected, and here I have the isolations. Now, of course, I need to set up a contact track on the CS. To do this, we now go to the CS, open the magnetic article list, and the plus symbol here is of course to add a new article. We then go to S contacts, and now you just need to make sure that in this selection up here, the GFP appears, or possibly an S link, but under no circumstances should you select control contacts here. Control contacts are something different. We'll talk about those later. So accordingly, we need the output for the GFP or for the S-link. Now I simply have contact 1, bus 1 on module 1, contact number 1, so everything is set up, and now we can test the contact accordingly. If I now simply place a screwdriver across my contact track over the two rails, bam, I get an occupancy report. That means my contact track is working. As long as something is on the contact track, I have the occupancy report, and when everything is gone, the contact is free again. That confirms the functionality of the contact. I can now unscrew it again, set it aside, and prepare it for installation. After I have tested all the contacts for functionality, the topic of contact tracks is finished for me, and I then turn to the next major topic on a layout, namely the last big one, the so-called signal sections. Here I don't just have signals, but I've also planned in brake modules, and now I'm going to connect everything that belongs together. However, all the stop sections that I have designated as stop sections here will be kept separate from the layout for now, and I'll prepare them for the next step. We will now work on signal section 1 on the test layout. We'll use this as a representative example for all the others to explain the principle of the stop section with the brake module. For this, I'll take the 3 responsible circuits and bring them to the front. That means in our example, the train comes from here and of course has to brake in this area. If the train accidentally overshoots here because it has such a long braking distance, it will automatically enter the emergency stop area where the locomotive is forcibly braked. And the first area is, of course, the so-called transition area, because there are differences between the railway and the power supply in the braking area, and to prevent a short circuit, I naturally need this transition track here, which essentially transfers the power from the normal supply to the braking area. And all these 3 rails that I have now pulled out here from the signal area must now be electrically isolated from the rest of the layout in terms of the center conductor. In this case, we again use our insulators, and on each track, both at the front and back, the tab responsible for the center conductor must be fitted with an insulating shoe so that no current can flow through here anymore. Now, of course, I have isolated the center conductor here, then also isolated the transitions from each other again. Here once more isolated the center conductor, and the same here, and finally on the other side as well. But that's not enough yet, because the track continues here with another rail, and as we've learned, the 2 tabs are connected to each other. That means on the counterpart of the track and also here where the track will later be connected, the center conductor also needs to be isolated again in that direction. This is our braking module, and as I already explained, the braking module has three sections. First, the signal section, then the so-called transition section. From here, we will later run a cable to this isolated track, which is the braking section. The yellow section is, so to speak, the spot where the locomotive is slowed down and also brought to a stop. In my case, there are two tracks as the braking section, but you can also choose a longer version. That depends on your preference. And if, for whatever reason, the locomotive goes too far out of the braking section when the signal is red, then it will end up here in the third isolated section, so to speak, and there the locomotive will be emergency braked. For this, I also have a separate track which is then supplied accordingly from this red section. When a green signal is switched on again, indicating that it is now safe to proceed, the signal module will release all three of these sections and switch them back to their normal track power state. The locomotives will then resume their journey as usual, continuing along the track. For that, of course, I now have to solder a red wire here, here and here so that I can later connect it to the braking module. Our layout is now quite advanced, which means we have implemented and pre-wired all the contact readers and have tested them accordingly. We have provided all the stop sections on the layout with the braking modules and pre-wired them accordingly. And what I also did in this step is that I added a feeder to this track, and I also added a brown and red feeder to the turnout here in order to distribute the digital current well later on the layout. This is not included in the plan, but I added it afterwards. I repurposed this track, and in the future it will serve as the programming track. Here as well, I soldered on the brown and red wires accordingly and completely separated the track, meaning the track power and the ground wire are isolated. This will later become my programming track. But before I drill everything, make the holes and screw down the tracks, I still need to do one small thing. All the turnouts still need to get their drive mechanisms and, of course, their decoders. In our case, we're using a built-in decoder. That's just a bit easier for me to implement because I don't have any wiring to deal with. So everything takes place within the C-track system. But you could also, under certain circumstances, do this with an M-track, but that would mean more wiring. This is our built-in digital decoder for the Märklin C-track as well as for the Trick C-track. And of course, this built-in decoder supports multiple digital formats such as the MFX digital format, as well as DCC and the Märklin Motorola digital format. However, in our case, we will be working exclusively with the MFX protocol since the CS can automatically detect and add this decoder. And the format I then use for switching is still either the Märklin Motorola or the DCC format. It depends on which one I choose. But you can also preset the address using the regular DIP switches that this decoder has. However, we won't be doing that in our case. That means I will carry out any necessary programming for the decoder after registering it on the CS, and that's also the biggest advantage of using the MFX protocol. So this is the turnout drive for the Märklin SEG track, and this is also the installation for the simple turnout. We will now equip this simple turnout with the drive and the decoder. As a representative for all other turnouts on the layout, the package of a turnout drive also includes this particular cable. We only actually need this cable if we want to switch this drive with an M or alternatively with control panels here. That's why we don't need this cable. And in the package of the turnout decoder, there are two wiring harnesses, and in this case, we also don't need this blue, white, red wiring harness. So this one can also be set aside. Now we take the decoder and the drive, and on the decoder we have the plug, which must be plugged into the drive the right way around. You should always do this before installing the whole assembly into the turnout, because it will be too difficult to do later. Yes, and then we take the power supply unit, which is specifically designed for the decoder, and it is also plugged into the correct interface accordingly, making sure that all connections are secure and properly aligned. Then after that, we have to place these two units, meaning both the power supply and the decoder, into the turnout, so to speak, ensuring that everything fits as intended. The corresponding mounts and screw connections, which are essential for stability and safety, are already prepared for this purpose. We just have to make sure, for example, that with the turnout drive, the tongue is properly positioned with the actuator of the turnout drive so that the tongue can actually be switched without any obstruction or misalignment. Yes, and then it's actually very easy to assemble, much easier than it might initially seem. First, we plug the drive into the R-DAM or EN position exactly as specified in the instructions, and then we can place the decoder next to it, making sure that both components are seated firmly. But before we do that, of course, we'll carefully screw the drive in place first, not too tightly, leaving a little play in case we need to adjust anything later on, which is important for fine-tuning the mechanism. Yes, and then we take the decoder, and the decoder is then plugged in next to the drive into these mounts where you can easily attach the decoder without any special tools. Now we just have to connect the two connectors to the rail, one for 0 and one for ground, ensuring that the polarity is correct and the connections are firm. This is now the ground wire to the long tongue, and then the power supply to the slightly shorter tongue, which is a crucial step for proper operation. In this way, I have tapped into the track power. The decoder only gets power and nothing else is connected at this stage. Now the decoder still has this yellow wire, which is an auxiliary supply, and that goes on the opposite side, again to track power, so to the shorter tongue, making sure that all wires are routed neatly and do not interfere with moving parts. And with that, the turnout is ready for operation once we've neatly arranged the cables, checked all connections, and ensured that everything is in its proper place and securely fastened. This careful preparation helps to guarantee reliable and trouble-free operation of the turnout system in the long run. Furthermore, you can of course set all the addresses here, but for us, only the last point is important, namely the toggle switch that determines whether the decoder switch is Märklin Motorola or the DCC format. Now we have equipped all the turnouts with decoders and drives accordingly, thus completing the final step of the installation. The next step would be to carefully align my tracks on the layout once again and then start screwing down each piece one by one. At the same time, I will also drill the holes needed so that the cables can be routed underneath the layout. This means that in the next video we will of course take a closer look at the wiring, and as the final step, the signals will be installed.